You're lazing around on the deck of the ship when you see something whitish-gray covering the horizon. Like in a horror movie or your worst nightmare, this weird fog is nearing the vessel. It's infinite. You can't see where it starts or where it ends. Soon it makes the ship look like a grain of sand in a vast desert. That's when the realization hits. It's an iceberg, and your ship is likely going to repeat the Titanic's fate. Now, all this is a very likely scenario, since the world's biggest iceberg, A23A, is on the move again after months of spinning in a huge water vortex. And it's actually the second time in just a couple of years that this massive chunk of ice has broken free. The first time was in 2023, when the berg went wandering around after being stuck on the seafloor for a staggering 37 years. The thing is huge, about 3 times the size of New York City. It also weighs nearly 1 trillion tons. The giant chunk of ice first broke off from Antarctica's Filchner Ice Shelf back in 1986, but instead of floating away, it got grounded on the seafloor just a few miles from where it started. Because of that, it melted much more slowly than most icebergs. In December 2023, A23A finally broke free and started to drift away from Antarctica. But it didn't get far before getting stuck again, this time near the South Orkney Islands. It got trapped in something called a Taylor column. That's a huge spinning water current that forms when ocean currents swirl around an underwater mountain. At one point, A23A was rotating around 15 degrees counterclockwise every day. Luckily, as of December 2024, the iceberg escaped the Taylor column and is now slowly moving again. Researchers are super curious to see if it'll follow the same path as other giant icebergs that have broken off from Antarctica, or if it'll find its own unique way. Such enormous icebergs, such as A23A, release nutrients into the water as they melt, and it can actually create hotspots of life in parts of the ocean that are usually pretty empty. But there's still a lot we don't understand about how the size, shape, or origin of the iceberg might affect that process. So, to figure it out, scientists have been collecting water samples from the areas A23A is expected to pass through, and they'll keep collecting samples as it drifts along. Hopefully, it'll give us a better idea of how massive icebergs like this one influence the ocean around them. By the way, the glacier our monster of an iceberg was once part of could be very, very old, literally ancient. In Antarctica, the oldest glacier ice might be close to 1 million years old. Over in Greenland, the oldest glacier ice is more than 100,000 years old. And in Alaska, the oldest glacier ice ever recovered, found in a basin between Mount Bona and Mount Churchill, is only about 30,000 years old, a mere child. At the same time, in a typical Alaskan Valley glacier, it only takes about 100 years for newly formed ice to travel through the entire length of the glacier. For something like Bering Glacier, which is Alaska's largest and stretches over 140 miles, the ice can move through the whole thing in less than 400 years. And that's a lot of movement for such a massive glacier. Now let's move on to Iceberg Alley, a stretch of the Atlantic Ocean that runs from the Arctic to Newfoundland. If you want to see as many icebergs as you can, that's the place to be. Tons of icebergs float through this place every year. Most of them come from Greenland. In spring and summer, big chunks of glaciers break off and get carried by north-south currents through Baffin Bay into the Labrador Sea, where they eventually melt. Some icebergs also come from Canada's shoreline, traveling through the Davis Strait and into the Labrador Sea before drifting along Newfoundland's eastern and western coasts. These massive ice chunks are really old too, about 10,000 years. Every year, about 400 to 800 medium and large icebergs pass through Iceberg Alley. How fast they drift depends on their size, shape, currents, waves, and wind, but the average speed is less than a half mile per hour. Now, there are 6 types of icebergs that make their way through Iceberg Alley. Tabular icebergs are flat slabs of ice, much wider than they are tall. Blocky icebergs have steep sides and sharp angles, like cut-off pyramids. Wedged icebergs have one steep side and one sloping side. Dome icebergs have a rounded top. Pinnacle icebergs have one or more steep peaks sticking up. And dry dock icebergs are U-shaped with a hollowed-out section. They all look incredible. Comment below which is your favorite type. Anyway, as these icebergs drift south, the warmer water speeds up their melting, making them pretty unpredictable and sometimes dangerous. Nowadays, satellites help track medium and large icebergs to prevent accidents, but smaller icebergs can still be risky for small boats. One iceberg made headlines in 2018 when it got unusually close to the Newfoundland village of Fairyland. Pictures of the giant iceberg towering over the village's houses went viral. It got stuck in a 330-foot deep water, which turned out to be too shallow for its massive size. And now I'll take you on an unusual journey to the past to witness the birth of something beautiful and equally disastrous. Its very existence led to one of the greatest tragedies in history. Watch, an enormous chunk of ice is breaking off a glacier in southwest Greenland. It's made of snow that fell over 100,000 years ago, when mammoths were still wandering around the planet. The enormous iceberg starts its long journey. It stretches more than 1,700 feet in length and weighs 75 million tons. Despite its size, it's pretty peaceful and stays far away from ships and the busy transport routes near where it was born. But then, it starts floating south, much farther than most icebergs ever get. Usually, icebergs like this melt way before they reach such warm waters. Out of the 15,000 to 30,000 icebergs that drift away from Greenland's glaciers every year, only about 1% make it all the way to the Atlantic. So the fact that this iceberg keeps going and reaches over 5,000 miles south of the Arctic Circle by April makes it truly unique. Even after months of melting, this block of ice is still incredibly massive. It weighs around 1.5 million tons, which is almost twice as much as the Golden Gate Bridge. Above the water, its visible parts tower more than 100 feet high. But like most icebergs, the majority of it, about 90%, is hidden below the surface. The iceberg's story takes a tragic turn on April 14, 1912, when, guess what? Yep, it comes across the ocean liner Titanic. The ship is about 370 miles from Newfoundland in the North Atlantic Ocean when the iceberg seems to appear out of nowhere. The crew doesn't spot it until just minutes before the crash. Why don't they see it sooner? That's a good question. Now, most people imagine icebergs as tall, bright, white chunks of ice, maybe even covered with snow. But in reality, icebergs come in all sorts of colors. Some are striped, patterned, or even have candy-like swirls, and they can also be black. There are two ways an iceberg can turn black. When the ice is extremely pure, with no bubbles or cracks, then it absorbs all the light instead of reflecting it, making it look black. Or a volcanic eruption can cover a glacier in ash. If ice from that glacier breaks off, it can have a dark or black color. Now, scientists still aren't sure why the Titanic's iceberg looked dark, or even if it really did. But one sailor who was on the lookout in the crow's nest said it seemed black. Another described it as gray or dark gray. One theory is this iceberg could have been a blackbird, which forms when the top part melts, causing the iceberg to roll over. If the bottom is smooth enough to absorb light, it looks dark. But even if the iceberg wasn't truly black, nighttime could have made it much harder to spot. Icebergs don't reflect much light, especially if they're jagged or vertical. They end up blending into the dark, shimmering ocean. Without radar, icebergs at night are incredibly hard to see, which is probably why the Titanic's crew didn't notice it in time. The Boxing Day Tsunami, Indonesia. An undersea earthquake starts in the morning. Its tremors cause a series of tsunami waves. The largest reaches the height of the Arc de Triomphe in Paris. Unzen volcano mega tsunami. A powerful volcanic eruption triggers a landslide from a 4,000-year-old lava dome. It sweeps through the city of Shimabara and reaches the sea, setting off a mega tsunami. The Vajont Dam mega tsunami, Italy. A landslide drags 9 billion cubic feet of forest, soil, and rock into the lake. A dark wall of water covers the sky over a tiny village at the bottom of the Vajont Dam. Then, with a deafening roar, the wave overtops the edge of the dam, taking out everything in its path. Mount St. Helens Mega Tsunami, USA. As the volcano erupts, the upper 1,500 feet of Mount St. Helens collapses into a massive landslide. Part of this avalanche plunges down into nearby Spirit Lake, which splashes the lake waters into a series of waves almost as tall as the Eiffel Tower. Alaska's Lituya Bay tsunami. A landslide caused by an earthquake creates a megawave. It surges over the headland and washes away trees, plants, and soil down to bedrock. Molokai, Hawaii. A third of the East Molokai volcano caves in and collapses into the Pacific Ocean. This causes a tsunami the size of the second tallest building in the world, Shanghai Tower. The waves reach Mexico and California. The Yucatan asteroid tsunami. The asteroid, which is rumored to have wiped out dinosaurs, strikes the Yucatan Peninsula. It creates a mega tsunami, the largest in Earth's history. The first waves almost twice bigger than the world's tallest building, the Burj Khalifa. Hurricane Mitch. Mitch forms in the western Caribbean Sea. Soon it strengthens to become the 8th most powerful Atlantic hurricane ever. The storm pours 4 inches of rain per hour for 2 days in Honduras. It causes terrible mudslides and floods. Hurricane Allen. Rare and extremely powerful, the storm is one of the few to reach Category 5, the highest possible. It causes more than $2 billion in damage. The Great Hurricane. After tearing down Barbados, the storm moves on. It strips the bark off the trees growing on Martinique and St. Lucia and travels further. This horrific natural disaster lasts for 6 days. Hurricane Dorian. It's the most powerful tropical cyclone to hit the Bahamas. The hurricane flattens most of the structures on the islands and sweeps them into the sea. Hurricane Wilma. The storm occurs in the Caribbean Sea near Jamaica and heads to the west. 2 days later, it gathers enough power to turn into the most intense hurricane ever recorded in the Atlantic Ocean. Hurricane Patricia. A regular storm develops a well-defined eye and turns into a Category 5 hurricane within a mere 24 hours. At one point, it travels faster than a Ferrari moving at its top speed. It makes Patricia the world's most intense tropical cyclone ever recorded. Kamchatka earthquake. It happens in the early morning 80 miles away from the shores of Kamchatka. The earth tremors produce a tsunami. The first 2 waves are catastrophic, up to 60 feet high. The third one's much weaker. Valparaiso earthquake, Chile. It happens at about 5 a.m. along the boundary of 2 tectonic plates. The tsunami, triggered by the earthquake, wipes out 620 miles of Chile's coastline. Tohoku earthquake, Japan. The first earth tremors start at a great underwater depth. The earthquake is so strong it moves Japan's main island. It shifts the planet on its axis by up to 10 inches and increases its rotation speed. The disaster also triggers a tsunami with 133-foot high waves that travel 6 miles inland. Indian Ocean earthquake, Sumatra. A rupture along 2 tectonic plates sets off an undersea earthquake. It begins at about 8 a.m. near northern Sumatra, Indonesia. It makes the planet vibrate nearly a half inch and sets off earthquakes all over the world up to Alaska. Good Friday earthquake, Alaska. The most powerful earthquake recorded in North America lasts for 4 minutes and 38 seconds. A 600-mile-long crack causes terrible landslides and a 27-foot tsunami. Areas 200 miles away get raised by 30 feet. Other places permanently drop 8 feet. Valdivia, Chile. The Great Chilean Earthquake starts in the afternoon and lasts for no less than 10 minutes. The disaster affects an area the size of California. It triggers tsunamis that reach the shore of Hawaii, Japan, the Philippines, Australia, and New Zealand. The average tornado usually lasts less than 10 minutes, but there are exceptions. El Reno tornado. It's considered the world's largest tornado based on width. At its peak, the twister reaches 2.5 miles across. The Perryville tornado, U.S. It occurs at about 2 a.m. and starts with snapping hardwood trees and breaking down stone constructions. Then the whirlwind becomes stronger. It levels two-story buildings, flips and tosses cars as if they were toys. Bridge Creek Moor Tornado. When the twister gets into the town of Bridge Creek, its width is at its peak, 1 to 1.5 miles. The wind speed of the tornado reaches more than 300 miles per hour. This natural disaster causes $1 billion in damage. Manitoba, Canada. An outstanding tornado rages for nearly 3 hours. It breaks tons of trees and utility poles, damages roads and farmhouses, but miraculously misses every town on its path. Tri-state tornado, U.S. The world's longest-lasting single tornado travels 220 miles through Missouri, Illinois, and Indiana. The average tornado's path is usually no longer than 5 miles. Tupelo, Gainesville, U.S. An outbreak that consists of at least 12 single tornadoes wipes out everything on its way. The accompanying rainstorms also trigger severe flash floods that make matters even worse. Valjean landslide, Italy. At 10 p.m., a landslide with a volume of 100 Great Pyramids of Giza breaks off from the top of Monte Toc. It falls into the Valjean Dam Reservoir, producing a tsunami wave taller than the Golden Gate Bridge. Yunnan, China. An avalanche of rocks, stones, and mud, so big it could fill up Sydney Harbor, forms a dam on the Jinsha River. The Hida River, Japan. Triggered by a rainstorm, 300,000 Olympic swimming pools of debris flows down before getting stopped by another, earlier landslide. Along the way, the landslide sweeps 2 buses off the road. Peru. A rock slide dams the Rio Montanero, a long river running through the center of Peru. The whole process takes no more than 3 minutes, which means the landslide moves at a speed of up to 87 miles per hour. It also leaves a trail of debris 5 miles long. The Usoy Dam, Tajikistan. Set off by a magnitude 7.4 earthquake, the rockslide falls into the Murghab River and blocks its flow. That's how the Usoy Dam, one of the tallest in the world, appears. Mount St. Helens, USA. At 8:30 a.m., after much buildup, a volcanic vent finally gives way and sets off a catastrophic eruption, which makes the entire north side of Mount St. Helens fall away. It's the world's largest recorded landslide. North Bonneville, U.S. In the middle of the 15th century, a great earthquake occurs. An incredible amount of debris rushes down from Table Mountain. It covers more than 5 square miles and blocks the Columbia River with a dam 200 feet high and 3.5 miles long. A bright flash on your left. Boom! Where did that lightning come from? Your plane shakes, your instruments stop working. A minute ago, the sky was clear and blue. Now it's pitch black. Your senses go haywire. You don't understand which way is up or down. It's a strange feeling. You're beyond time and space. Lightning flashes from all directions. Clouds envelop your plane and swirl it into a vortex. You grip the controls and repeat to yourself, "I'll get out of this. I'll get out." Through the dark and thick clouds, you see a ray of light. It's your only chance. Your plane flies toward the light like a moth to a flame, and whoosh! You break out of the terrible whirlwind. Your instruments are back to normal. The plane's no longer shaking. You're saved. That's how pilots who faced the Bermuda Triangle anomaly describe their experiences. Well, at least on TV shows. The huge chunk of ocean between Miami, Bermuda, and Puerto Rico remain the planet's most mysterious area. But it's not alone. Alaska has its own triangle. Since the late 80s, 16,000 people have disappeared there. Eyewitnesses to the Bermuda Triangle anomaly talk about thick fog, lightning, balls of light, and hallucinations. In Alaska, everything's a bit more complicated. People, planes, ships, they just disappear without a trace. There's no one around to tell us what it felt like. In 1950, a plane took off from Anchorage, Alaska, headed for Great Falls in Montana. It was carrying 8 crew members and 36 passengers. 2 hours after the start of the flight, the captain radioed in that everything was fine. Then, silence. The 100-foot-long plane seemed to evaporate into thin air. 85 aircraft and around 7,000 people search for the plane. No trace. Not even a screw, bolt, nothing. That plane mystery made the Alaskan Triangle famous. If you look on a map, it's a wild and mostly unpopulated zone that passes near Anchorage, Barrow, and Juneau. If you connect the dots on a map, you get an epic triangle. You can fit the whole state of Oregon in it twice. If you read around, you'll find a bunch of major areas on the planet where weird stuff keeps happening over land, sea, desert, and jungle. Scientists have many questions about these places. They all have extreme electrical and magnetic anomalies. Planes and ships disappear in them. People hear stuff, see stuff, and here's some of them. China's Black Bamboo Valley looks like a Hollywood set for a seriously scary movie. Here, everything's creepy and mysterious. Ha, perfect. Imagine a bamboo forest that stretches up 130 feet. The green plants live extremely close to each other and barely let in any sunlight. A strange fog hangs in the air. Where it comes from and why it's always there, no one knows. And the mysteries don't end there. For centuries, people have disappeared in the vast forest. Scientists believe the site's crazy geology is to blame. Cracks can suddenly appear in the ground big enough to fall into. There are sharp changes in weather, and maybe even poisonous steam. Certain trees give it off when they fall to the ground. There's a long road through Ladakh in India. It's called the Magnetic Road. It slopes upwards and seems to violate the laws of gravity. Here's what happens. You drive to the foot of the hill, turn off the engine, and get out of the car. The car starts rolling uphill up to 12 miles per hour. Why does it happen? Theory 1. The hill has an incredibly strong magnetic pull, and it attracts cars once they get too close. The Indian Air Force supposedly avoids flying over it to avoid any interference with their equipment. Version 2. It's all just an optical illusion. The hills around it seem to fade into the horizon. It looks to us like the road is sloped up, but it's actually not. Huge Lake Michigan looks more like a sea than a lake. And over the past 400 years, 6,000 ships have disappeared in it. Why does it happen? The lake has its own mysterious triangle, and there are actually more unsolved mysteries here than in the famous Bermuda Triangle. In 1950, Flight 2501 disappeared over the lake, en route from New York to Minneapolis. The fate of the 3 crew members and 55 passengers remains unknown. In 2007, an underwater archaeology professor was surveying the bottom of Lake Michigan. He found stones arranged in a circle 40 feet down from the surface. They kind of look like Stonehenge in England, but why were they at the bottom of a lake? Who put them there? Archaeologists found a carved pattern on one of the stones. Its outline resembles a drawing of an animal. Now, that's not unusual, except that this particular animal, which looks like a mammoth, was probably carved around 10,000 years ago. Sleep is very difficult for the Venezuelan locals who live near Lake Maracaibo. Right at the place where the Catatumbo River flows into the lake, there are huge electrical storms that can go up to 10 hours long. 260 days a year. That's over 1 million lightning bolts over the lake every year. Scientists don't know exactly what causes the daily lightning parties. Some people think it's due to the gas methane which comes out of the ground. Other scientists blame uranium deposits in the soil. Nowadays, though, most researchers are sure that the lightning's caused by weather. Cold mountain air smashes against warm sea air. The result? A lot of friction and moisture, the perfect combo for near-nightly natural fireworks. It's super loud and kind of annoying if you live nearby, but the area is really important for the planet. It helps regenerate our vital atmospheric ozone. And the one that started it all, the Bermuda Triangle. Planes, ships, all gone without a trace. The theories are endless. Scientists even think there might be a huge meteor at the bottom of the sea that emits its own magnetic energy. It might have confused the navigation equipment on all those unlucky carriers. And it's been going on for a while. Researchers think that it was causing trouble even way back in Columbus's time. As far as Alaska's concerned, magnetic anomalies are a dime a dozen. Around here, your compass might be off by 5, 30, or even 60 degrees. But equipment malfunction isn't really enough to explain the disappearance of so many aircraft and people in this absolutely massive state. Alaska is wild. High mountains, never-ending forests, snow in the winter, and some serious heat in the summer. There are 3 million lakes, 12,000 rivers, and around 100,000 glaciers. There's only one person per square mile. California has over 250. You could walk for days, weeks, even months without seeing anyone, except maybe a bear or two. And the days and nights can be really confusing this far north. Tourists from all over the world dream of coming to Alaska to see the planet as it was before. No concrete jungle, no endless roads, warehouses, and cornfields. But this isn't just a beautiful place. It's also an incredibly dangerous place. You can get lost in the forest, run out of food, get soaked to the bone, lose your compass or GPS. In the harsh conditions of Alaska, danger's always just around the corner. Most vacationers just aren't prepared for that. 80% of the state's communities aren't connected to the road system. Back in the Wild West, horses carried people, products, and information. In Alaska, it's all about planes. Alaska has 9,000 aircraft and 8,000 pilots, and counting. That's more than 1 out of every 100 Alaskans. Sudden weather changes, frequent and wild rain, snowstorms, and fog. Not a great recipe for a smooth flight. The wings on Alaskan planes can get covered with ice. The fog can hide the snowy mountaintops, and strong gusts of wind can knock a tiny plane way off course. That's what those pilots have to deal with every time they take off. So, that plane that disappeared? Investigators believe that the Douglas C-54 Skymaster disappeared due to bad weather, and any debris was covered with snow or fell into a lake. 5% of Alaska is covered in glaciers, and there are loads of cracks in them, some big enough to fit a person, a few people, or even a whole airplane. Now, at first glance, it seems like we're on a giant raft called a continent that's just floating around on some molten lava until it hits another continent. Okay, let's make a quick stop at high school science class. Our home planet is like a cake with different layers of ingredients stacked up on top of each other. The Earth's core, mantle, and crust. Hey, where's the frosting? The cake batter on top represents the crust of the Earth, made up of 3 types of tasty rock: igneous, sedimentary, and, say it with me, metamorphic. These rocks are formed in different ways, such as from solidified lava or from the deposits of particles and minerals. The crust is what we stand on, a home to our continents, oceans, and everything we see around us. Then you have the mantle, not the baseball player, the layer that lies right below the crust. Many people think that the mantle is just lava, but it's not quite like that. Just like how you mix different ingredients in the cake batter, the mantle is made up of different types of rocks that are constantly moving and shifting. And finally, we get to the sweetest part of the cake, the center, or in the case of Earth, the core. It has 2 parts, the outer and inner core. The outer core is made of molten rocks and metals that are incredibly hot. Ow! Even hotter than the surface of the sun. The inner core is solid, even though temperatures there are crazy. It doesn't turn into liquid because the pressure down there is amazingly strong. When you see all this, you can easily think that below us there are endless miles of lava and hot rocks. So, how come tectonic plates move at all? The continents don't float on a sea of molten rock. The oceanic and continental crusts really sit on a mantle. Sure, there's a layer of liquid rock in our planet, the outer core, around 1,800 miles below the surface, but it's separated from the surface by the mantle that's thick and solid. So, the Earth's tectonic plates move around because they're on a thick layer of solid rock, the upper mantle. Basically, this rock is under incredible pressure and heat, which makes it flow in slow motion over time. Think of it like honey or syrup that you pour over your cake layers. As you move the cake around, the honey or syrup will also move and flow. Similarly, the upper mantle can flow and drag the parts above it along, just way slower than honey. and the rock is both breakable and flexible. It can crack and break like a cookie, now I'm getting hungry, but it can also stretch and bend like a piece of taffy. When the plates get caught on each other, they can't move anymore, but when they break free, they start drifting again, like puzzle pieces shifting around until they find their perfect fit. Extremely high temperatures and pressure are the reason this flow happens. It's like a big pot of soup on the stove. As the soup heats up, it starts to move around, carrying heat from one spot to another. Is it lunchtime? And speaking of lunch, lava, it's not just molten rocks that travel all the way up from the outer core to volcanoes. When tectonic plates come together and one slides underneath the other, they create a lot of heat and pressure while grinding against each other. It's like rubbing your hands together fast and they start to get hot, or when you start a fire with rocks. And as the melted rock, or magma, rises to the surface, it can create volcanoes. Now, long ago, the Earth's land was not divided into continents as it is today. Instead, there was one giant landmass known as Pangaea, meaning all Earth in Greek. Whoa! Imagine being stuck in the middle of this giant ocean. So, over time, this supercontinent slowly broke apart. Its parts drifted away from each other and formed the separate lands we call continents. This idea first popped out in the 16th century when one cartographer realized the coastlines of Africa, America, and Europe appear like they could fit together like puzzle pieces. Later, researchers realized the rock composition of their coastlines was similar, which means they used to be part of one giant mass, and they call that the theory of continental drift. At first, people were pretty skeptical about that idea because they didn't know how such massive lands could move around. Now, we'd all be able to explain that part, right? So, the Earth's crust is divided into a couple of large plates and many smaller ones. All of them are still moving, even though it's in slow motion. We can't sense it, and we won't see any particular changes during our lifetime. It's a process that lasts hundreds of millions of years. As the plates move, they interact with one another in fascinating ways. For example, when two plates collide, one may be forced beneath the other, which would help create a subduction zone. Over time, this is the way you get many cool things like volcanic islands, trenches, and even entire mountain ranges. Plates apparently started moving around 3.5 billion years ago. It took them a while to group into the first jigsaw supercontinent we know about called Ur. Today, its remains make up parts of Madagascar, India, and Australia. Pangaea formed 335 million years ago, but it probably won't be the last continent that will form. So, some new generations in the distant future could live on something called the next Pangaea. When the oceanic crust of the Atlantic Ocean slowly takes its place under the continental crust, the oceanic basin of the Atlantic is going to close, which is why the continents will end up pulled together. This means the Americas will meet Africa, and Eurasia will be flipped on its side. So, people might live on a giant landmass in the shape of a ring, clustered around the inner sea, or at least what's left of it. Or maybe continents will take another direction and make up a different jigsaw puzzle called Amasia. In this scenario, the Americans will drift westward, fuse with Australia, and pivot to around Siberia. And then there's more. Novo-Pangaea is the option where the Americas swing together to embrace Antarctica and Australia, and Africa legs off to the northwest. Basically, all continents here get together to form a giant landmass that stretches from one pole to the other. Ready for one more? Nah, come on. A recent projection called Eureka gives an idea similar to Novo-Pangaea. It's just that all continents here unite to become one gigantic land that clusters around the equator. Maybe this would be my favorite one to live at, with the sunny weather and the beach all the time. And who knows what kind of magnificent trenches, mountains, islands, and other geological beauties we'd get with this giant supercontinent. Pangaea broke up about 175 million years ago. As the Atlantic and Indian Oceans began to widen towards the east, the Ring of Fire was formed. It's a path that goes along the Pacific Ocean with so many frequent earthquakes and active volcanoes. This way, Eurasia was unable to cross this border and continue moving westward. And now Eurasia could move laterally along the Ring of Fire. The subduction zones kind of act like a barrier that forces the tectonic plates to move in different directions. So Eurasia could eventually collide with the Americas and form something similar to Amasia. It would be cool to sit there, grab the popcorn, and watch it from the side. But this is something that won't happen for the next 50 million years at least. I'm willing to bet I probably won't be here to see it. Different theories talk about different positions where this new supercontinent might end up one day. But it seems it will probably be somewhere in the polar area, centered on what we today recognize as the Arctic Ocean. Not my cup of tea. Bring me back the sunny one. Wait, scratch that. Let's go eat. Wow, talk about noisy! Toadfish have a unique ability. They can create a very strong sound. The human ear usually can't hear it, especially if only one fish is making the sound. But if many fish are making the sound at the same time, well, it's going to be hard to forget, and you may not be able to stop hearing it. Toadfish are a common part of the fauna off the coast of Sausalito in California, and every year thousands of them gather in the shoals to party and scream. Together, they create a collective sound that can be easily heard by those in the houses near the shore. The noise, which can be described as a low hum, can even penetrate into the city center. Some people get bothered by this constant humming. This is a unique natural phenomenon, but there's a catch. At some point, the fish swim away from the shore, but the sound remains. Also, scientists have proven that this fish-made noise can't spread through the city, and many residents of the coastal areas don't hear it. But still, some people continue to hear this strange hum. In a similar case, imagine that you've moved to a small village in Scotland. You rent a house, have dinner, and go to bed. As you're settling into sleep, a strange hum permeates your room. It sounds like someone started their truck somewhere in the distance. The sound is similar to the sound of a low, loud bass that comes from a speaker. The hum keeps you awake. You get migraines and even feel nauseous. In the morning, you find out that some other locals also hear this terrible buzzing. They tell you about a huge factory located nearby. Machines, engines, steam boilers, big air vents, and generators emit a loud, heavy hum that passes through the air. Sound waves spread throughout the village and annoy people with a sharp sense of hearing. You've been hearing this sound for several days and suffering from insomnia. Then, one day, the factory goes bankrupt. All the workers leave their positions and turn off all the engines and fans. Great, you'll finally sleep in peace. But you know what? The sound doesn't disappear. It follows you wherever you are. And it's not about the factory or the fish or the truck engine. Imagine that you're walking down the streets of a small English town. There are a lot of planes flying right above you. The hum they make follows you. Even in bed you can hear it. You wonder if there's an airport nearby. You ask the locals and find out there's not even a runway here. But where does the sound come from? You raise your head to look up and see a clear sky. There are no planes, but there's noise. And you're not the only one who hears it. Some locals are sure that the hum comes from high-speed traffic on the highway. Thousands of cars drive in two directions and leave massive sound waves behind. But at night, there are no cars there, and the sound remains. Maybe you're going mad. People's stories about the hum save you from this madness, and it's not just the residents of this town that know about it. About 4% of people on the planet hear the hum. Strangers tell each other about the hum that prevents them from sleeping and concentrating on something. The sound follows them everywhere and doesn't stop. Some people hear it in certain places, so they move to other cities. Maybe you're hearing it right now and not paying attention. But be careful. If you recognize it once, you won't be able to stop hearing it. There's a website and a forum on the internet dedicated to the hum. People from all over the world put geolocations in places where they heard this mysterious phenomenon. You can find thousands of these coordinates on the site and even add your own. People describe different levels of noise and share their sources. Some theories say that the hum is the sound of our planet coming from the core. Someone else is sure that it comes from the atmosphere. Scientists have even been consulted, but they also don't know the reason for this phenomenon. People use high-frequency microphones and amplifiers to record the hum. Almost everywhere, they detect a low-frequency vibration that is practically impossible for the human ear to catch. It mixes with the sound of cars, printers in the office, and subway trains. Sometimes people stop hearing it, but the hum increases when they lie in bed. Many records about the hum say that people hear it in industrial cities. Sometimes these sound seekers manage to find the source. They ended up being factories with running generators where the sound was getting into the ventilation system and where the fans spread it outside the building. When the generator stopped working, the sound disappeared. But these are rare cases. More often, no one can find the source of hum. One of the most famous places where you can catch it is in the city of Taos in New Mexico. About 2% of locals hear a strange buzzing every day. Some tourists experience it too. Scientists came to the city to study this mystery, but found no explanation. Some theories say the usual acoustics of this place cause the hum. Some folks think it's just a hallucination or the power of suggestion. Everyone talks so much about the hum that the brain creates an illusion of a sound that doesn't exist. Locals believe the nature of the buzzing is mystical and associated with bad spirits. Whatever it is, no one has found out the truth yet. The hum that people hear all over the world may be the result of seismic activity in the tectonic plates under the ocean waters. Huge chunks of the Earth's crust are slowly moving and colliding with each other. This creates a noise that reaches us in the form of a hum. But why do only a few people hear it? Perhaps about 4% of the world's population has a unique sense of hearing. In any case, scientists haven't been able to confirm the tectonic plate theory either. Some researchers point to submarines as the reason. They use low-frequency radio signals to communicate around the world. These signals spread over the surface and can affect the human body. When the ear catches these sound waves, it reacts and causes vibrations similar to humming. This happens because low-frequency sound energy collides with the soft tissues of the skull and stimulates the auditory nerve. In fact, it's not even a sound. It's a hallucination that is created by your brain. But still, no one can confirm this theory either. Perhaps thunderstorms can create the hum phenomenon. About 8 million lightning strikes hit the Earth every day. Some impact creates a powerful electromagnetic charge. Lightning penetrates the air and makes it resonate between the Earth's surface and the ionosphere. Yeah, it sounds complicated, but the principle is simple. Imagine that you're blowing onto the neck of a bottle. Hear this low hum? Lightning works similarly with air. And that's just one hit. Imagine millions of these strikes. The sound waves spread all over the planet, and some people hear them. Lightning constantly strikes all the time, so the hum never stops. In 1973, scientists put forward a theory that the reason for the hum is the jet stream shearing against slower-moving air. In simple words, wind and fast air flows intersect slower ones. As a result, a whistling sound appears, and electric towers and power lines amplify it. By the way, the first reports of the hum appeared in the 70s. People learned about this phenomenon from the small British city of Bristol. Dozens of residents heard this strange noise in different parts of the town. In the beginning, they ignored it. Then the sound became increasingly more irritable. It prevented people from working and living their everyday lives. They couldn't sleep and couldn't concentrate on anything. There was a warehouse with industrial fans in a neighboring town. The locals were sure that this was the reason for the hum. The warehouse stopped working a few years later, but the sound remained. You may even be able to hear it right now if you visit the city. There are many theories about the hum, but you can reduce almost half of them thanks to one factor. Tectonic plates, seismic activity, lightning strikes, the Earth's crust, and resonating air are logical explanations. But look at all the records about the noise. People hadn't mentioned this until the 70s. If this phenomenon had appeared earlier, many newspapers would have written about it. Apparently, the hum is not a mystery of nature. Perhaps this is a consequence of all of our technological achievements. Factories, power lines, airplanes, cars, ship, trains, microwaves, and generators create an imperceptible background noise that most people ignore. We're so used to all these noises that we have forgotten what silence is. Perhaps our brain made the hum inside our heads to respond to our noisy world. If you start to listen carefully right now, what kind of sounds will you hear? Where are they coming from? And is there the hum among them?
The latest super eruption of Yellowstone occurred 640,000 years ago, and it was long before Homo sapiens saw the light of day. But we were around during another, no less devastating natural disaster. This super eruption took place on the island of Sumatra around 74,000 years ago. That's when an erupting supervolcano wreaked havoc on huge territories, sending up plumes of debris and ash that spread for thousands of miles and caused temperatures on the planet to plummet. The effects of this super eruption were visible as far away as southern Africa. Experts believe they could have impacted early humans there. By the time the volcano erupted, our ancestors had already been using stone tools and had likely known how to produce yarn. And some specialists even think that the Toba super eruption was so powerful it could push our ancestors to the brink of extinction. They claim that Toba might be the largest volcanic eruption to occur on Earth within the last 2 million years. The eruption disgorged so much pyroclastic rock it would be enough to cover the entire United States to the depth of a one-story house. About a third of that deposit piled up on northern Sumatra, while a lot more ended up beneath the floor of the Indian Ocean. The super eruption left an elliptical crater lake around 60 miles long. The caldera is so large it's hard to feel that you're indeed in a volcano. Pumice deposits from the eruption remain in the canyon walls and go deep below the ground. There aren't many arguments about the amount of pumice and ash involved in this disaster. At the same time, experts aren't sure how much sulfur ended up in the atmosphere. Even some sulfur layers in the polar ice could be potential candidates. But so far, scientists haven't found any connection between them and Toba. But let's get back to the dramatic impact the super eruption had on early humans. It turns out some not only survived but even thrived after this natural catastrophe, at least judging by the artifacts they made during and after the eruption. The disaster might not have posed a serious threat to those of our ancestors who took refuge along the coast. Genetic evidence hints that modern humans descend from a few thousand people that ventured out of Africa around 60,000 years ago. Why just a few thousand? According to some experts, the rest of our ancestors could have been devastated by the Toba eruption. After all, the supervolcano spewed out 1,000 cubic miles of dust and rock in a flash, leaving a scar in the ground that was dozens of miles wide. All that dust and sulfur Toba sent into the atmosphere potentially cooled the surface of our planet, which led to the appearance of glaciers and the lowering of Earth's sea levels. And since Toba might have had an important role in shaping humankind, scientists have been working hard trying to understand precisely how early humans reacted to this disaster. In 2011, several researchers found an enigmatic soil sample in South Africa's Pinnacle Point, an archaeological site overlooking the Indian Ocean. This sample contained some volcanic ash. After examining the layer, they found more than 400,000 artifacts left by early humans. Those ranged from heat-treated stone tools to signs of fire and animal bones. Based on this finding, the team suggested that early humans on the South African coast thrived after the eruption, living in that area for thousands of years and improving their tools. The region might have served as a refuge during and after the Toba eruption. A 2009 study suggested that the eruption could have lowered global temperatures by 14 degrees Fahrenheit. It would have made survival tough elsewhere in Africa. If there had been a volcanic winter, it wouldn't have been as cold along the coastline. On the other hand, newer studies claim that Toba spewed out so much sulfur into the atmosphere that the resulting aerosols could have stuck together, which would have limited their cooling effect in the long term. In other words, right after the eruption, temperatures would have plummeted, but only in some regions. And after 3 years or so, the effects of the eruptions would have calmed down altogether, becoming not dangerous to humans. Well, apparently, more research is needed. Meanwhile, let's figure out if we should watch out for any volcanoes these days. Last year, thousands of small earthquakes shook the ground near Iceland's Svartsengi geothermal power plant. Magma rose to the surface there, and now it has opened wide fractures slicing through the small town of Grindavik. The ground there is still swelling, and an eruption might happen with little notice. But of course, that's not all. Over the planet, 45 other volcanoes keep rumbling. For example, Italy's Vesuvius, that infamous thing that finished the city of Pompeii in 79 CE. Over the last 17,000 years, the volcano has experienced 8 explosive eruptions, followed by powerful pyroclastic flows, dense masses of super hot ash, lava fragments, and gases flowing at high speeds. The volcano's last eruption happened in 1944. Mount Rainier is one of the most dangerous volcanoes in the USA. Its high elevation, chemical composition, and proximity to Washington's Seattle and Tacoma suburbs, and the volcano's ability to produce massive pyroclastic flows make Mount Rainier a threat to consider. The heat from this volcano could potentially melt the ice and snow covering it, leading to rapid downstream flows of debris, mud, and rocks. The Novarupta volcano in Alaska's Katmai National Park and Reserve formed in a 1912 eruption, which was the world's largest in the 20th century. The volcano sent almost 7 cubic miles of ash and debris into the air. It also produced such a powerful ash flow that it created the Valley of 10,000 Smokes. Mount Pinatubo is located in a populated region in the Philippines. It became notorious after a 1991 massive eruption, which was the second largest eruption of the 20th century. More than 700 people lost their lives during that natural disaster. Today, more than 21 million people live within 62 miles of Pinatubo. Mount Agun, a continuously erupting volcano in Indonesia, had its last major eruption in 1963. It was one of the most tragic eruptions in the country's history. It lasted for 11 months, producing ashfall and pyroclastic flows that led to the loss of more than 1,000 lives and serious property damage. People saw ash plumes above the volcano throughout 2018, following the eruption in November 2017. Japan's Mount Fuji hasn't erupted since 1707. That year, a massive earthquake likely set it off. In 2014, experts warned that Fuji could be at risk of another eruption following the 9-magnitude earthquake that shook Japan in 2011. Experts believed the earthquake had raised pressure below Fuji. The eruption in 1707 sent so much ash and debris into the air that all this mass even reached Tokyo. Should Fuji erupt again, it would affect more than 25 million people in the surrounding areas. The eruption of Washington's Mount St. Helens in 1980 was one of the most destructive volcanic events in U.S. history. 57 people, as well as thousands of animals, lost their lives during that natural disaster. The eruption also destroyed around 200 square miles of forest. Experts think that Mount St. Helens' history of massive eruptions means that future catastrophes are bound to happen. The next explosive eruption might send large amounts of ash all over the Pacific Northwest. No wonder the volcano is under close monitoring. One of Indonesia's most active volcanoes, Mount Merapi, has been erupting for centuries. NASA claims that the biggest risk of this volcano is pyroclastic flows, which can spread over vast areas and harm loads of people. For the last time, Merapi erupted in January 2024, sending plumes of smoke into the air. These days, more than 24 million people live in the area surrounding this volcano. Phew, you can finally send that last report for the day and breathe out. The weekend is around the corner, but just when you're about to hit send, you're alarmed by the low rumbling under your desk. Is it the light rail passing by? Unfortunately, that's not the case. It's a volcano speaking. What, here? In Arizona? That's right, the ground keeps shifting under Arizona, reminding us that Earth is alive. No panic though, let's arm ourselves with some context. 20 American states have extinct, active, and dormant, currently sleeping, volcanoes. Among such states, you can find California, New Mexico, Nevada, Utah, and Colorado. On the bright side, Arizona's volcanoes are dormant at the moment, but it doesn't mean they won't go off in the near or not so near future. Now, how about traveling to Arizona to check the traces of its active volcanic past? They dot the desert landscapes of this state like spots dot a Dalmatian. There are entire volcanic fields southwest of Phoenix, east of Douglas, near Flagstaff, north of Kingman, and near the Mexico border. The most worrying thing about these fields is that even though they're not active at the moment, eruptions in this region might happen every 1,000 years or so. Well, the time seems to be up. The last powerful and destructive volcanic eruption occurred around 1,000 years ago at the Sunset Crater. Oh, this place is worth paying more attention to. And we will, but a bit later. First, we have to talk about hotspots. No, not that place where you can surf the web. In our volcanic context, a hotspot is a place where insane amounts of heat melt the overlying crust, Earth's thin outer layer, and form volcanoes. This heat rises from the mantle, which is located between our planet's dense, superheated core and the crust. Want to see an example of this type of volcanism? Welcome to the Hawaiian Islands. The Big Island has its active volcanoes because, at the moment, it's situated on top of the Hawaiian hotspot. The older Hawaiian Islands were once there too, but later they drifted off towards the northwest. It happened because that's where the oceanic crust on top of which they sat, namely the Pacific Plate, moved. Now, look at the world's ocean basins. Yes, they're literally dotted with islands that sit on top of hotspots, like Hawaii, Iceland, Samoa, the Galapagos. Those are probably the most famous examples. But don't think that continents can't host hotspots. They can, but those are far less common. One of the most famous continental hotspots is, I bet you know it. Yep, the one beneath the Yellowstone caldera. By the way, the caldera is a vast volcanic crater, especially one formed as a result of a massive eruption that led to the collapse of the mouth of a volcano. The Yellowstone hotspot is basically the creator of Old Faithful and the rest of the hot springs and mud pots for which the national park is famous. Speaking of Old Faithful, let's make a small detour and pay more attention to this wonder of nature. It's one of the most well-known geysers in the world. People have been coming from all over the globe to see it for more than a century. The cool thing about this geyser is that the likes of it can only form under very specific conditions. That's why they're pretty rare. Magma under the surface superheats pockets of underground water. The pressure there keeps growing until it eventually pushes the water upward with immense strength. A certain volcanic rock with a high silica content lines the tunnel through which this water escapes. Basically, it creates a unique pipe that can withstand unbelievable pressure and heat created by the water erupting above the ground. Old Faithful was the very first named geyser in Yellowstone. If you come to visit it expecting the thing to erupt every hour on the hour, you're gonna be disappointed. On average, Old Faithful erupts every 91 minutes or so, which isn't that bad either. Plus, you can download a special app which will provide you with the approximate time of the next eruption. But be very careful while visiting and stay away from the site. The water erupting from the powerful geyser reaches 204 degrees Fahrenheit. The steam is even more scorching, up to 350 degrees Fahrenheit. It's hot enough to bake a cake. But let's get back to our volcanic hotspots. Scientists still don't clearly understand why there aren't many hotspot volcanoes on continental crust. One reason might be that the continental crust is much thicker than the oceanic crust, which is about 4 times as thick on average. Another reason could be that most of Earth's crust, about 2/3 of it, is oceanic. This means that there's less continental crust for hotspots to form under. Now, I bet those of you living in Arizona will appreciate the following info. We'll talk about a volcanic field right in the heart of this state, the San Francisco Volcanic Field. That's a massive area filled with over 600 volcanoes. Yes, they're mostly small, but it doesn't make them any less impressive. They're scattered across 1,800 square miles in northern Arizona, a giant territory. Interestingly, scientists are still debating about whether this volcanic field is actually sitting on top of a hotspot. But one thing they agree upon, the volcanoes in this area get younger as you move east. And this pattern matches up with the North American plate moving west over what could be a stationary hotspot beneath the surface of our planet. Cool, huh? The volcanic hullabaloo in that area started around 6 million years ago. So, in geological terms, it's relatively young. As for the most recent eruption, it happened less than 1,000 years ago. The Sunset Crater, which I mentioned before, the one near Flagstaff, is the most famous vent from that eruption. The Sinagua people had to leave their homes at Wupatki Pueblo because of the eruption. That site is now part of the Wupatki National Monument. There, you can see how people lived in this volcanic region many years ago. If you go to explore this area, you'll notice that most of the volcanoes there are basalt cinder cones, small and steep. The Colorado Plateau has quite dry weather conditions. That's why the volcanoes haven't worn down much. Some of the best examples of those cones, like this one, called the SP crater, still look like they appeared yesterday. But look around. It's not just cinder cones. The San Francisco Volcanic Field also has a stratovolcano, as well as some lava domes that formed from volcanic rocks with more silica than basalt you can find in places like Hawaii. It means they're thicker and don't flow as easily. Anyway, the stratovolcano is going to be one of the most epic sights you'll come across while exploring this volcanic field. Well, not the stratovolcano itself, but the San Francisco peaks, the remains of that giant formation. They stand tall at more than 12,600 feet. That's 4.5 Burj Khalifas placed on top of one another. It makes the peaks some of the biggest landmarks in northern Arizona. They're not only stunning, but also sacred to the Native American people who have lived in the area for many generations. Now, unlike those super active volcanoes in Hawaii, the San Francisco Volcanic Field takes its time, thousands of years between eruptions. But you shouldn't relax just yet. Geologists say another eruption is likely to happen one day. It will probably occur in the remote eastern part of the field, away from big towns. Phew! And if that next eruption is anything like the one that formed Sunset Crater, it would be quite the show. Lava fountains and rivers of lava flowing. At the same time, the next eruption might not happen for centuries, maybe even millennia. Until then, the San Francisco Volcanic Field will remain a hidden gem of volcanic history, waiting for its next fiery performance.
When you think of a volcano, what's the first thing that comes to mind? Streams of red, steaming hot lava pouring over the sides? Dark clouds of ash rising high into the sky? Maybe you think of a relaxing hot spring. Ah, that's nice. Well, we all imagine one thing, a cone-shaped mountain looming over the horizon. But it can be as green and lush as any other mountain. At the top, of course, there's a giant hole, like an opening that goes all the way down. Inside, there's lava and gases being pushed outside. Lava is so hot that if you were standing at the top of the volcano and looked down, your face would feel as red as the color of that liquid rock oozing out. A volcanic eruption never comes without consequences for us. And I'm not just talking about people living nearby. The impacts are usually felt on a global scale, too. Can't fly for a while because of the blanket of ash released in the air. Not to mention, it might be a bit tricky to breathe. Carbon dioxide, sulfur dioxide, and plenty of other toxic gases whose names immediately take you back to your high school chemistry class. Funny enough, most of that cloud rising out of a volcano is just water. Well, vaporized from those scalding temperatures. But before any volcano erupts, it goes through stages like an angsty teen. First, magma, that's lava before it erupts onto the surface and gets its name change, starts moving underneath the volcano. This causes earthquakes that get worse and more dangerous over time. Then, steam and different gases start spewing out of holes in the planet's crust. Our Earth resembles a tea kettle about to whistle. When the gas emissions and earthquakes get more massive, it usually means the volcano is about to blow its top. But those first stages can take years before an eruption happens. Then, the magma starts building up. With more and more pressure, it's planning to make its great escape. It's hard to notice this happening if you don't have the proper equipment. Good thing scientists do, and they've got us covered. The volcano becomes more active by the minute. Ash starts coming out and spreading in the air, creating ominous clouds that turn day to night. With the magma building up, an eruption is imminent. Then, boom! The surface gives in under the pressure below. The magma makes its exit. It's now lava, spewing out the top and flowing down the sides of the mountain. None of this sounds very appealing. So, what if it never happened? What if there were never any volcanoes at all? Would Earth still be the same? Not at all. If volcanoes never existed, there wouldn't be an atmosphere. When our planet was still just a young pup, volcanic gases are what created our protective bubble that allows you and me to breathe right now. They also played a big part in shaping the land and oceans. 4 billion years ago, Earth was still forming. It didn't look anything like the pale blue dot we know today. It was red hot, and the water was trapped under the crust. It wasn't until the surface started to cool down and solidify that the water was finally able to escape. Volcanoes acted sort of like a tear in the fabric of our planet. Water vapor would condense in the atmosphere and then fall back down as rain. It rained for so long that the third planet from the sun started turning into the blue ball we're more familiar with. In fact, there's even a theory that all the water on Earth came from volcanoes. And without water, of course, life wouldn't have been able to form. Land formation went through a similar process. You see, our planet was a pretty rough place to be when it was forming. It was a molten surface with fields of lava and constant volcanic eruptions and space rocks always crashing into it, because there was no atmosphere to protect it. When it started cooling down, a good solid surface formed, but the hot material underneath was still boiling and bubbling, and it continued making its way up. The crust would move and form thick layers with the material that was rising up. Over time, these layers became more permanent. Volcanic eruptions were still happening, but the first landmass had finally formed. Okay, we'll take the best part of volcanoes, an atmosphere. So what if they stopped erupting long after we got our protective breathable shield? Still not good. For starters, volcanoes created the most fertile soil. Around Naples, you have the famous Mount Vesuvius. The soil quality there is incredibly rich, and that's thanks to 2 huge volcanic eruptions, one that happened 35,000 years ago and another 12,000 years ago. Sure, these volcanoes caused a lot of short-term damage, but in the long run, these soils were fertilized by them. Now the region grows all kinds of citrus fruits, olives, grapes, cherries, and of course, their staple, tomatoes. There'd be none of that without rich volcanic soil, and Naples is by far not the only example like this. Bacteria, the first living organisms, lived in hot water. Scientists have discovered fossilized microorganisms older than 4 billion years. They thrived in hydrothermal vents. Those are fissures on the sea floor, and they're usually near volcanically active places. This means that without volcanoes, we wouldn't have land, water, or even the first life forms that, as the theory goes, would eventually evolve into all the creatures we have today. Could life have still developed on Earth without these explosive mountains? Doubtful. Okay, fair enough. We want our atmosphere and life. So let's say volcanoes stopped erupting today, after we already have all these benefits. Well, we're sort of already there, based on this story. At the start, there was only one continent, Pangaea. It was a supercontinent surrounded by one massive continuous superocean. Volcanic activity by this time had finally calmed down, and this meant all that energy would gather below the Earth's crust. Here's a little diagram. First, we have the Earth's inner core. Then there's the outer core. Next up, we have our convection currents. Magma is next in line. After that, the oceanic crust. And at the very top, we have our ocean and our continental crust. The reason Pangaea eventually broke up into the separate continents we have today is because of plate tectonics. It's not like the crust is all one solid piece. It's broken up into big chunks, or plates, that are always moving. And it's all still moving today. Yes, the land you're standing on right now is sort of surfing on that layer of convection currents. It's a slow process, so it's not like you can feel it. Pangaea didn't break apart all at once. It took tens of millions of years. When the plates move, they cause earthquakes and volcanic activity. They create mountains too. It's good for our planet as well, because the Earth gets to sort of renew its old crust. If there was no volcanic activity now, the pressure underneath the Earth's crust would keep building up. It'd get to a boiling point the continents couldn't handle anymore, and eventually, they'd start splitting into more numerous and smaller masses. Volcanoes are still useful to us till this day. For one, they cool our atmosphere. Their eruptions release sulfur gas. It combines with water in our atmosphere and cools it at its lowest level, which is where we live and breathe. There's also an excellent use for their heat. Geothermal power plants harness the energy coming from deep inside the Earth and turn its heat into steam. We then use that steam and turn it into electricity. This is the case for our friends in New Zealand and Iceland, since they live in places with high underground temperatures. Volcanic material can also be made into blocks for building stuff. It can be grounded down to make cement too. If we want, we can even search volcanoes for precious minerals like gold, copper, and sulfur. And who can forget about hot springs? Tourism to places like Yellowstone and Iceland wouldn't be the same without them. And who doesn't love a nice steamy dip in the ones safe for swimming? Oh yeah. In the end, volcanoes aren't so bad after all. Our beautiful Earth wouldn't be what it is without them.
In the high altitudes of northern China, there is one mountain that remains frozen all year round. It's a naturally occurring spot of cold earth. A thick layer of permafrost lies underneath the mountain's top layer of soil, freezing everything above it. The climate-defying pocket of frozen land covers over 26 feet of a mountain slope in Pingchuyen County, a place famous for its scorching hot summers, reaching highs of 90 degrees Fahrenheit. This frozen spot of land manages to survive the blazing temperatures due to the coarse blocky layer of soil covering the permafrost. This coarse soil prevents the hot climate from reaching and melting the permafrost, allowing the ground to stay frozen all year round. Argentina may be famous for its beautiful beaches and hot sun, but in southern Argentina, you can find Perito Moreno Glacier. This stunning blue glacier covers over 100 square miles and is constantly growing. When visiting this natural wonder, you might notice an archway of ice forming off the side of the glacier, reaching out to the nearby land. Suddenly, the archway ruptures and the ice collapses into the water below. This is completely natural. The glacier goes through a process of forming these arches until they collapse. It'll form another one in no time. On California's Glass Beach, there's no sand and only colorful gemstone-like pebbles called sea glass. Surprisingly, these beautiful pebbles are the result of garbage. For decades, the beach was used as a massive dumping ground for locals to abandon their glass, appliances, and even cars on the beachfront. The state eventually prohibited anyone from disposing of their garbage on the beach. Over the years, the waves broke down all the remaining junk and turned it into brightly colored pebbles that attract tourists from all over. The highest waterfall in the world, Angel Falls, can be found in southern Venezuela. The water there travels along one of the biggest tabletop mountains in Venezuela and plummets 2,500 feet down into the jungle below. That's 3 times taller than the Eiffel Tower. The water falls from so high that most of it evaporates into mist before even reaching the ground. Visitors can feel the mist settling on their skin from over half a mile away. In Scotland, hidden away from the main roads and tucked deep within the woodlands, is Fiddick Glen. This area looks like something out of an ancient fairy tale, with looming glass moss-covered rock formations and crimson red waters. The water's red color is due to the red sandstone lying beneath the shallow river. To get to this stunning natural beauty, you have to embark on a dangerous hike down steep, muddy hills, clambering onto trees to stop you from falling. But when you reach the bottom, it'll all have been worth it to watch the sunlight shine off the ruby waters and see the towering rocks of this enchanting world. With bubblegum pink water and a surrounding circle of emerald green forests, it's hard to believe that Lake Hillier is a real place. Located in Western Australia, no one can truly explain why the lake has pink color. However, scientists have theorized that the high quantities of salt in the lake have attracted a salt-loving pink bacteria called halobacteria, responsible for the lake's trademark shade. In a small peninsula in South America, there is one of the most beautiful natural wonders in the world, the Marble Caves. These look like any other caves from the outside. Inside these caves, the walls consist of smooth, swirling blue marble formations. Over thousands of years, water has eroded the marble deposits within these caves, forming this unique cave system. So while deep blue color seems like it's part of the marble, it's the reflection of the water that causes these blue shades along the cave walls. Azerbaijan's mud volcanoes are exactly what they sound like. Over 300 of these natural phenomena are located in Azerbaijan, more than anywhere else in the world. There have been over 200 eruptions since records began. Mud volcanoes are landforms caused by the eruption of mud, water, and gases. Pockets of gas form underground and force their way to the surface, eventually erupting and splattering mud everywhere. These volcanoes can be pretty dangerous. In 2006, a mud volcano erupted in Indonesia and coated an entire nearby village in thick mud. Pamukkale is a marvelous hillside of tiered thermal pools. The name of the Turkish city translates to Cotton Castle. The pools are made of travertine, a type of limestone that gives the hillside its stunning white color. In addition, the stone has geothermal properties, making the pools hot springs. There are 17 pools in total, and all are open to the public 7 days a week. The temperatures range from 95 degrees Fahrenheit all the way to 212 degrees Fahrenheit. They are essentially nature's version of a hot tub. Legend has it that the Giant's Causeway in Northern Ireland was formed when a great Irish giant was challenged to battle a Scottish giant. The causeway was built across the sea so the two giants could meet. When the Irish giant defeated his foe, the Scottish giant ran home and destroyed the causeway behind him. All that remains are the beginnings of the causeway at the water's edge. The stunning rock formation of interlocking columns was the result of an ancient volcanic eruption. The columns are a hexagonal shape and form a natural staircase from the Irish Sea to a foot of a cliff. The tallest columns are 39 feet high. The Giant's Causeway is the most popular tourist destination in Northern Ireland, receiving almost 1 million visitors in 2019. Deep within the Nika mines in Mexico, you can find the Cave of Crystals. The cave is full of massive shards of bright selenite crystals. The largest is 37 feet tall. These are some of the largest natural crystals in the world. It's thought that the water that previously filled the cave was incredibly rich in minerals, allowing the crystals to grow to their full potential. Unfortunately, tourists cannot visit the Cave of Crystals due to its scorching temperature and humid conditions. Even scientists are required to have a special permit to enter the cave. The River of Five Colors is located in the Colombian province of Meta. Known locally as the Rainbow River, the waters are famous for their striking colors. The river is variously colored yellow, green, blue, black, and most prominently red from summer till winter. Due to a lack of nutrients, the river's water is naturally clear, so it's easy to see diverse and colorful plant life on the riverbed. It's these vibrant plants that give the waters its many colors. In New Zealand, you can take a boat ride through the beautiful Waitomo Caves. The walls of the caves glow luminescent, like bright stars against the night sky. But these glowing lights aren't stars, they're worms. Luminescent glowworms live in the walls of the cave, giving the cave its trademark glow. The particular species of glowworms cannot be found anywhere else in the world. For thousands of years, the fairy chimneys have stood tall in Cappadocia, Turkey. These unusual rock formations are tall, thin spires of rock that were initially formed by lava. The tallest chimney is 130 feet high. Humans have hollowed out the insides of these rocks for hundreds of years to create homes for themselves. Today you can visit one of the many hotels that currently exist inside the fairy chimneys. Wave Rock is a popular spot for a photo shoot in Western Australia. The giant rock is 46 feet tall and shaped like a breaking ocean wave. Millions of years of strong winds and hard rainfall eroded the rock into the wave-like shape it has today. The rock has a stunning mix of red and gray colors caused by minerals washed down the rock. The site of the Wave Rock has become a famous camping ground due to its proximity to beautiful lakes and a variety of wildlife. The Zanyi National Geopark in China has previously been voted one of the most beautiful landscapes in the world. The park is famous for its colorful rock formations, popularly known as the Rainbow Mountains. Layers of minerals and different colored sandstone were slowly pushed together across 24 million years to create the stunning landscape.
Antarctica, a snowy world of about minus 46 degrees Fahrenheit, covered in ice for millions of years. But it wasn't always this way. Scientists just found something buried deep beneath the seafloor that shouldn't exist. Tiny golden droplets of amber. This means that Antarctica was once teeming with life and thick with trees. But something happened to it. Something that could reshape the way we see our own future. Antarctica has been a land of howling winds for millions of years. No tree can grow here today. But scientists who studied those lands decided to drill deep beneath the Antarctic surface. They went thousands of feet below the ice, pulling up ancient layers of sediment. And there, trapped in time, they found tiny pieces of golden amber. Amber is basically fossilized tree resin. It's found all over the world, often with perfectly preserved pieces of ancient life. Insects trapped mid-flight, pollen frozen in time. Entire tiny ecosystems can be locked inside golden droplets. In every continent, but not in Antarctica. Until now. They discovered tiny specks from 0.5 to 1 millimeter in size, smaller than a grain of sand, but with huge significance. This droplet had once oozed from the bark of a tree about 90 million years ago. What's even wilder, amber is only produced by certain types of trees, the ones that grow in humid, temperate rainforests and jungles. That's when the realization hit. Antarctica used to be a rainforest. Those tiny flecks of amber, clearly seen only under a microscope, tell us a vivid story of a living and breathing ecosystem. Around 90 million years ago, during the Cretaceous period, when dinosaurs ruled the Earth, Antarctica could have been covered in lush, swampy forests filled with towering conifers, ferns, and ancient plants. Some of the fragments showed signs of damage. That means the trees that produced them had been injured, perhaps by wildfires or parasites. Though despite that, and despite the fact it spent millions of years on the seafloor, this amber was almost perfectly preserved. Solid, transparent, and free of cracks. Normally, amber buried under extreme pressure and heat just crashes over time. But this piece, it survived. That means other pieces could survive as well, and we might find more of them on the ocean floor. But this wasn't the first sign that Antarctica had once been a different place entirely. It started in 2017. A team of scientists drilled deep into the seabed near Pine Island Glacier on Antarctica's west coast. They pulled up sediment cores, long cylindrical samples of Earth that had been buried for millions of years. And it was insane. Inside these layers, they found fossilized roots, pollen, spores, traces of an ancient forest that had once thrived here. And that's exactly what they'd been studying ever since then. In order not to damage anything, they had to spend years of hard work, breaking down the sediment into thousands of tiny pieces and scanning them all under fluorescent microscopes. The same team also found another piece of the puzzle back in 2020. They found more sedimentary samples from the ocean floor that pointed to a land of dense trees, rivers, and wetlands. A world that looked more like the Pacific Northwest or New Zealand. But why was Antarctica so warm back then? Well, that's all because of the atmosphere. 90 million years ago, Earth's carbon dioxide levels were terrifyingly high. It was literally one of the warmest periods in history, with temperatures soaring even at the poles. Think about it. Antarctica had no ice caps. Instead, it could have had buzzing insects and maybe even dinosaurs wandering through its forests. But in order to learn what happened to them, the team has to find more evidence. Antarctica really is a place full of mysteries. It's hard to study because it's covered in snow and ice so much that we don't even know its true shape and size. Some parts of the ice sheet are over 3 miles thick, half the depth of the Mariana Trench, the deepest trench on Earth. Luckily, snow has a great quality. It can freeze things in time perfectly. Layer by layer, year after year, it buries nature's past like a time capsule. Luckily, snow has a great quality. It can freeze things in time perfectly. Layer by layer, year after year, it buries nature's past like a time capsule. At first, fresh snow is soft and shifts easily in the wind, full of air. But as more snow piles on top, it compresses, squeezing out the air pockets and hardening into dense ice. This freezing pressure locks everything inside. It traps ancient plants, animals, and even entire landscapes. And they literally get frozen in time, because the extreme cold slows down decay. It stops bacteria growth, preventing rot, and keeping things almost perfectly intact for thousands, sometimes even millions of years. That's exactly what's going on in Antarctica. Scientists have to literally scan it all the way down this snow in order to find what this place looked like millions of years ago. What they found is an entire lost world buried under miles of ice. It was beneath the thickest ice of East Antarctica, near the Aurora and Schmidt subglacial basins. The weight of the ice has been so immense for so long that it actually protected the land from erosion. Scientists call it the ghost of Antarctica's landscape, and it's nothing like the smooth, flat wasteland seen from above. They found rivers that once flowed freely, now frozen in place, valleys carved by water, even 3 massive, sharply peaked hills. But what are they? To understand that, we need to go even further back in time, to the era when Antarctica was still part of a lost supercontinent. Hundreds of millions of years ago, the land we now call Antarctica was part of Gondwana, an enormous supercontinent that included South America, Africa, India, Australia, and Antarctica all fused together. But as Earth's tectonic plates slowly drifted apart, Gondwana broke into pieces. Antarctica was ripped apart, its land stretched and fractured. The massive ice sheets that formed later covered these broken landmasses, preserving them like frozen fossils. As the ice shifted and melted over time, valleys formed, and ancient rivers likely carried water toward a coast that was hundreds of miles away from where it is now. But that's not the only thing Antarctica has hidden. If you stripped away the ice, you wouldn't see a smooth, empty continent. You'd see a super dramatic landscape, towering mountains, deep valleys, even fiery volcanoes. In West Antarctica, at least 138 volcanoes are buried under the ice. One of them, Mount Erebus, is still active. And inside, it has warm volcanic caves where you could walk in a t-shirt. Oh, and if it wasn't weird enough, Erebus is also spewing out gold. Yep, the actual tiny specks of gold from deep within the Earth. Scientists believe this happens because magma, the superheated semi-molten rock beneath the Earth's surface, carries liquid gold with it as it rises. Every single day, Erebus releases about 0.2 pounds of it. That's worth around $6,000 per day. In a year, that adds up to 64 pounds, or more than $2 million, floating into the sky. Unfortunately, before we grab shovels, we gotta remember that those are just microscopic particles. They're often smaller than 60 micrometers, thinner than a human hair. Not even mentioning that they're scattered around up to 620 miles away from the volcano itself. Finding them is nearly impossible. But that just shows that even in such a harsh place that looks just like a white desert, there are still many fascinating mysteries to discover. For example, somehow, life still clings there. In 2017, scientists drilled deep beneath the ice of the Ross Ice Shelf looking for water. But they found something fantastic instead. A river hidden beneath 1,640 feet of ice, running through the dark. And inside it, hundreds of tiny shrimp-like creatures. They swarmed around the camera, blocking the lens, welcoming the scientists. In deep caves beneath the ice, DNA evidence has also shown traces of moss, algae, and possibly even unknown tiny animals. So, turns out, even in one of the harshest places on Earth, life finds a way. And who knows what else we'll discover in the South Pole? These dark patches on Greenland's ice sheet aren't just any old stains. Every summer, the ice, which is usually bright white, turns murky gray in certain areas. This so-called dark zone was a huge mystery for a long time, until some studies discovered that this weird transformation was connected to the odd appearance of red, green, and brown-colored algae. The scariest part is that this algae bloom keeps growing. The dark zone is getting darker, and terrifying microbes might start appearing. Now, the rest of the world should be concerned. The Greenland ice sheet is like a massive ice blanket that covers around 80% of the island. It's so thick that it holds about 8% of the world's freshwater ice. For most of the year, the ice looks like a giant untouched white sheet stretching over the land. But when summer rolls around and temperatures start to rise, things begin to change. The ice melts, revealing rocky areas along the coast. And as you move further inland, that once smooth white ice becomes darker. This is the dark zone, and it covers an area of around 248 miles in length and 62 miles at its widest point. This weird phenomenon happens basically for two reasons. The first one is black carbon. Just like dust that builds up on your bookshelf, the ice in Greenland has the same issue. The wind carries a mix of dust and soot to this icy area. But unlike your bookshelf, you can't just wipe it off with a cloth. In Greenland's case, this dirty mix settles on the ice and sticks around for thousands of years. So, the dark zone is basically covered in a fine layer of dust that's built up over time. Back in 2014, researchers analyzed this dirty mix and found that the darker ice areas were filled with black carbon. This black carbon didn't just appear out of thin air. Well, actually, it sorta did. Scientists believe it mostly comes from smoke produced by wildfires in northern Canada and Alaska somewhere in the past. As you might guess, black carbon is black, which is why it makes the ice look darker. Now, the second big reason for the Greenland ice sheet's summer makeover has to do with those algae we mentioned earlier. We're mostly talking about two types of it, the Ancylonema alaskana and the Ancylonema nordenskjoldii. Both of them love cold water regions. During winter, they stay in a dormant state deep within the ice. But when spring comes, they start to slowly migrate to the surface. By the time summer hits, they're ready to bloom and soak up nearly 24 hours of sunlight each day for photosynthesis and growth. Normally, these algae are green, but when exposed to sunlight, they turn brown, as a natural way to protect themselves from harmful ultraviolet rays. And this color change is also what makes the ice in Greenland look darker. So far, this has been normal behavior. What's really alarming is that these algae blooms are getting bigger and bigger every year. This happens because they thrive on phosphorus, a nutrient that's plentiful out there and comes from a mineral called hydroxylapatite. This mineral is found in a type of rock that breaks down into tiny dust particles, which are then blown across the ice by the wind. As the climate gets warmer, the rocks dry out more, and stronger winds carry more dust. More dust means more phosphorus, leading to more algae growth. See? It is a cycle, and it keeps getting worse every year. Studying this is crucial to understanding why the dark zone keeps getting bigger. From the year 2000 to 2012, its size increased by 12%. But you might be wondering, why should we care? After all, it's just ice getting darker, right? Well, not exactly. Think about how you can't stand wearing black clothes on a hot, sunny day. They soak up the heat and make you feel even hotter. That's because darker surfaces absorb more sunlight. The same thing happens to ice. Together, dust, black carbon, and algae blooms are responsible for about 70% of the variability in albedo on the Greenland ice sheet. Albedo is just a fancy word for how reflective a surface is. If you take two surfaces, one white and shiny and the other dark and rough, the white one will reflect a lot of light and heat, giving it a high albedo. The dark one, on the other hand, will absorb more light and heat, so it has a low albedo. During the summer, the Greenland ice sheet experiences a reduction in albedo. This means the ice absorbs more sunlight, and when ice absorbs more sunlight, it melts faster than it should. This is why understanding what's happening in the dark zone is so important. It helps predict how quickly the Greenland ice sheet is melting and how it can affect the rest of the world. Greenland's ice sheet is the second largest in the world, covering an area about the size of all the land in the United States east of the Mississippi River. And its huge mass of ice averages a thickness of 1.4 miles. Unfortunately, the ice loss has skyrocketed. Back in the 1990s, Greenland was losing about 25 billion tons of ice per year. Now, it's losing around 234 billion tons per year. That's nearly 10 times more ice melting away each year. According to NASA, if all of Greenland's ice sheet were to melt, it would increase global sea levels by about 24 feet. That could be catastrophic for coastal countries and cities around the world. The Netherlands could be submerged, the Bahamas could be almost completely wiped out, and many of the Philippines Islands would be at risk of disappearing. All of this may seem like a distant reality, and it is true that most scientists believe it would take several hundred or even thousands of years for the ice sheet to melt completely. But it is important to know that Greenland didn't always have this thick layer of ice. Very recently, researchers took a close look at some sediment from the bottom of a 2-mile deep ice core extracted from the center of Greenland. They found that the soil had traces of willowwood, insect parts, fungi, and even poppy seeds. So these fossils are the first direct evidence that Greenland's ice sheet melted away in the recent geological past, around 400,000 years ago. At that time, Greenland was home to a green tundra landscape with insects and plants. This discovery is both fascinating and scary because it shows that the ice sheet collapsed before and might be more fragile than scientists originally thought. There is another concern too. A recent research collected meltwater from different spots on the Greenland ice sheet and found that the water samples were packed with hundreds and thousands of microbes. The concern is that they could be released into the ocean in the future. And some studies already suggest that areas near where a lot of glacial meltwater flows have a higher risk of viruses jumping to new hosts, like from animals to humans. Even though experts believe the chance of a doomsday virus coming from the glaciers is very small, it's still not zero. The truth is, we don't know much about the thousands of microbial species living on the surface of the ice, and there is simply not enough data to fully understand how dangerous these organisms might be. All of this might sound concerning, but we shouldn't panic just yet. There's still a lot we don't understand about what is darkening the Greenland ice sheet. We still need more detailed measurements of the relative abundance of dust, algae, and black carbon, as well as a better understanding of how these potentially dangerous microbes could affect our lives. The more we learn, the better we can predict what's going to happen and how we can prepare for it.
So it turns out that you can't drive between South America and North America, and there's a simple reason for that. There are no roads connecting the two continents, not even a rudimentary one. Technically, you could try your luck crossing on foot, but let me tell you, that would be a huge mistake. The region that connects the two continents is called the Darien Gap. It stretches across southern Panama's Darien province and the northern part of Colombia. The only land route there is a 60-mile jungle trek. Crossing it can take anywhere from 3 to 10 days. It depends on weather conditions, how much you're carrying, and honestly, just pure luck. Chance plays a big role here, because this isn't some chill, relaxing nature walk. It's a harsh, extreme environment, known for being completely isolated and one of the most dangerous places on Earth. Still, people seem to forget that and go there anyway. Every year, the number of people crossing just keeps growing. In 2014, fewer than 10,000 people crossed the gap. In 2023, that number increased to 520,000. Now, you might be wondering, what are so many people doing in the middle of the two American continents, risking all that danger? Well, that's because the Darien Gap has become a route for refugees migrating to North America. But to get there, they face all kinds of dangers, from insect bites and infections to serious fractures. We're talking about a no-man's land. Since there are no police stations, immigrants must also watch out for thieves. Along the way, they have no choice but to rely on and support each other. Most people start the crossing with at least a tent or tarp, rain boots, water, and some food. But these things get heavy fast, and people normally can't carry enough supplies for the entire journey. At some point, people start drinking river water to avoid dehydration. But the water's full of bacteria and dirt, so it causes intestinal issues. And if things get serious, there's no medical help there. To make this whole scenario even worse, the temperatures are brutal, often hitting over 95 degrees Fahrenheit. Now, a small subset of people who venture through the Darien Gap are hardcore adventurers and travelers looking for a survival experience in the jungle. But this region is no place for a relaxing vacation. A group of tourists who went there in 2023 ended up getting jungle rot, a fungus that affects the feet. The situation got so bad that a woman had to be carried out by the group on the last day because she couldn't walk. No matter how prepared people are for the Darien Gap, in the end, survival mostly comes down to luck. Out there, travelers won't find cities with solid infrastructure where they can crash at a hotel and gear up for the next day. In some spots, they might stumble across basic camps right in the jungle. These camps might offer wooden platforms for tents, bucket showers, toilets, and even plates of chicken and rice. But it all comes at a price. Wi-Fi, for example, might cost $2 an hour, and that seems like a pretty good deal, considering there's no cell phone service on the trail. They pretty much lose all contact with the outside world. Now picture a dense rainforest with steep, muddy terrain. The hiking trail is littered with boulders and tangled with vines, like nature's own tripwires. It climbs sharply over a mountain, becoming a serious challenge even for someone in good physical shape. The area also gets constant heavy rainfall, which can lead to landslides, flash flooding, and extremely muddy conditions. The situation gets so intense that even the t-shirts and faces of those who make the crossing end up covered in mud. They'll also have to cross a lot of fast-moving rivers. A Venezuelan dad who recently went through the area with his 2 kids said their sneakers ripped apart on the very first day. That's how powerful the rivers can be. And they're deep, too. Sometimes the water reaches all the way up to their shoulders. But the dangers in that area aren't recent. For centuries, the Darien Gap was thought to be impossible to cross. The first Europeans who ventured into Latin America saw it as kind of a jungle training school. They totally knew about its dangers, but still, many adventurers tried to make the crossing in the years that followed. In 1854, for example, an expedition disappeared for 49 days in the jungle, battling starvation and exhaustion. Then again, in 1870, a group of 100 men set out to cross it. Even though they were well prepared and carried cutting-edge equipment for the time, they still suffered tremendously during the journey. They had to rely on incredible resilience to survive the challenge. Over the years, people who ventured in often ended up passing away from hunger, thirst, and even drowning in rivers. They also faced the risk of being attacked by dangerous animals like jaguars, white-lipped pecaries, and the fer-de-lance, a fast, irritable snake that is one of the most venomous out there. The area is also swarming with mosquitoes, which can spread serious health problems. Leaning against trees to rest can also be risky. This jungle is full of spiked chunga palm trees, which are covered in long black spines up to 8 inches long. Unfortunately for us, these spines are covered in all sorts of bacteria. Just brush against a chunga, and you could end up with infected wounds. And yet another danger is getting lost in the dense forest and never finding your way back to safety. These days, though, this risk is a lot lower. Some people have mentioned color-coded markers that help guide travelers and keep them from going the wrong way. If they see blue or green fabric tied to trees, it means keep walking. But if they spot red fabric, that's a sign they're going the wrong way and need to turn around quickly. Since there are so many dangers, why not just build a road through the Darien Gap? While it might seem like a good idea, building a road connecting Panama and Colombia isn't really that simple. The Darien Gap has a humid climate, tough terrain, and constant rainfall, which means any attempt to build a functional road would be highly challenging and super expensive. Even though there have been previous attempts to fill in the gap. See, there's a huge road system called the Pan-American Highway, which stretches all the way from Alaska to the southern tip of Argentina. Nowadays, this highway hits a roadblock right at the Darien Gap. But it wasn't supposed to be like this, as the original idea was for the road to go through there. Leaders from Latin American countries tried to make this plan happen in the 70s, and then again in the 90s. But a lot of people were against it, mainly because they wanted to protect the local communities and the rainforest. Since the Darien Gap is mostly untouched by humans, it's one of the most biodiverse places on the planet. It's believed that 1 in 5 species are endemic to the region, meaning they only exist in that specific area, like the Darien pocket gopher and the slatty slender mouse opossum. A road would have really damaged the ecosystem in the area, so the plans were scrapped. Eventually, an alternative was created to travel by sea. At least 2 companies started a ferry service connecting the 2 countries. However, the business wasn't profitable, and they ended up shutting down. Not long ago, Panama decided to close the Darien Gap route. Now they're sealed off with barbed wire fencing. It might just be a matter of time before other routes are created. But if you are an adventurer looking to visit South America, it's probably not best to wait for that. Traveling by plane to Colombia will always be a much safer option. When we think of active volcanoes, one region comes to mind: the Ring of Fire in the Pacific Ocean. 3/4 of Earth's volcanoes sit within this belt. Compare the area to Australia, which doesn't have any volcanic activity. The old continent of Europe is also calm, or at least we like to think so. Can you guess what the most active volcano in Europe is? If you thought of Mount Etna on the island of Sicily in Italy, you were right. The volcano has erupted about 200 times and has been far from sleeping in recent decades. The last time this happened was in August 2023. The highest mountain in the Mediterranean is 500 million years old. But in Iceland, there is a much younger volcano. It sprang into action on the 10th of July 2023. In the afternoon, 3 fissures appeared in the ground on a peninsula in the southwest of the island. This was at a base of a small mountain peak. Its name means Little Ram in the local language. The volcano spewed molten lava high into the air. There were also gas plumes in the area. But the scientific community wasn't surprised by the event. They already knew about the volcanic area that stretches between the cities of Reykjavik and Keflavik. Its name is hard to pronounce. Hey, I want to buy a vowel. It had already erupted during the previous 2 summers. This activity came after 8 centuries of dormancy. In the days leading up to the latest eruption, seismologists, the scientists who study earthquakes, recorded over 12,000 tremors. When the ground opened up in July, the fissures were over 1.5 miles long. The following morning, 2 of them closed. All the lava was now coming out of the last fissure. It grew into an elongated cone, the simplest shape of volcano we are all familiar with. The lava soon filled a large crater. It grew almost 100 feet tall during the first week, and it is still growing. On the night when the eruption started, lava spread out in all directions. Its cinders set ablaze the dry moss in the vicinity. Local authorities closed off the surrounding area. There were toxic gases from the volcanoes and smoke from the burning moss. Firefighters flocked to the area. After a week, they proclaimed the area safe. Visitors soon came to witness the birth of Europe's youngest volcano. This form of tourism is quite developed in Iceland. People come from all over the world to watch active volcanoes. The land of fire and ice is home to more than 130 volcanoes. Some 30 of them are active. Now, I know what you're thinking right now. Is volcano tourism safe? In Iceland, it is. The country's authorities research and constantly monitor all of the hotspots. The island is dotted with several dozen seismic stations. These help researchers accurately predict future eruptions, and emergency services are accustomed to these sorts of events. They can quickly cordon off danger zones. This is what happened in 2010. A volcano in the south of the island, the name of which everyone struggled to pronounce, erupted. It spewed out a plume of steam and ash that was 7 miles high. This wasn't a fun time to be an air traveler. Winds carried the enormous plume southeast toward northern Europe. Many countries closed their airspace for several days for safety reasons. The volcano erupted in March, but the Earth was shaking from January the same year, so seismologists knew that an eruption was approaching. When it comes to the continent's youngest volcano, the tourist infrastructure is already there. Visitors can leave their cars at a designated parking lot. Then they go on a 5-hour-long trek. This leads to a viewing deck. Tourists are so close to the epicenter that they can feel the heat haze from the crater. The sight is the most impressive at nighttime. Safety is never a concern. Scientists regularly chart out hazard maps that outline the borders of lava fields. This way, visitors who stick by the rules are never in harm's way. More than a week after the eruption started, a section of the crater collapsed. Lava flowed downhill west of the volcano. This majestic smoldering hot river is slow-moving lava. Scientists categorize it as an AA type. The term is Hawaiian. It describes basaltic lava that has a rough and brittle surface. The flow is composed of broken lava blocks that are called clinkers. They fall off as the substance flows. This reveals red-hot areas. The cooler sections of lava are gray and black in color. When it moves forward, it produces a distinctive sound like shattering glass. Nearly a month after the eruption of the new volcano, we got aerial footage of an interesting phenomenon. A tornado formed directly over the lava flow. This occurs due to the high temperatures in the area. When the conditions are right, a column of heated air can easily turn into a mini tornado. Scientists observed a similar event happen during the 2018 eruption of Mount Kilauea in Hawaii. The lava fields of Europe's second-largest island tell the story of the creation of Iceland. It sits above the place where the North American and Eurasian plates meet each other. Tectonic plates are huge, rocky chunks of Earth's most outer layer. There are roughly 20 of them. They rest on a partially molten layer of rock. All the lava we see on the surface starts its journey here. You could say that these plates float on molten rock. Their boundaries are unstable, so when two plates grind past each other, they release tremendous amounts of energy. The formation of volcanoes is one result. These are places where the molten rock travels upward to the surface. Iceland began to form some 60 million years ago. The tectonic plates under the ocean drifted apart. Enough lava piled up on the surface to create solid ground. This ancient rock is under the waves today. As new lava reaches the surface and cools down, it pushes the old rock away from the center of the island. That's why the oldest parts of Iceland aren't 60, but only 16 million years old. The country's active lava fields are young in geological terms. Some of them are under 1,000 years old. Scientists consider the island a hot spot for volcanoes, pun intended. Nearly a third of the basaltic lava that reaches the Earth's surface in recorded history came from Icelandic eruptions. Fissure swarms, like the ones before the 2023 eruption, cover 30% of the Nordic country. For this reason, only a quarter of the island is inhabited. Norse Vikings were the first people to settle in Iceland at the beginning of the 10th century. Nature threw them a loud welcoming party. Just a few years after their arrival, they witnessed one of the greatest volcanic eruptions in history. Vikings came from a region without volcanoes, so they had no clue as to what was going on. Today, Icelanders are used to such events. This is good because their homeland is entering a new era of volcanic activity. Volcanologists suspect that recent events are an introduction to decades of more frequent eruptions. The peninsula that is home to Earth's youngest volcano is just 17 miles southwest of Iceland's capital city. It's been dormant for a long time. Present-day eruptions there are a reminder that the natural processes that created Iceland are still ongoing. Recently, scientists discovered that there's a historical link between volcanic eruptions in the north of Europe and glaciers. Our planet went through at least 5 major ice ages. These were exceptionally lengthy periods when the average temperature on Earth dropped. The result was the expansion of ice sheets across northern Europe and North America. The last ice age ended some 10,000 years ago. Researchers are still trying to fully understand how these glacial periods affected volcanic activity. They suspect that the sheer weight of all that ice disrupts the flow of magma underground. When glaciers retreat, the pressure is lifted. This makes it easier for lava to flow upward to the surface where it bursts.